All right, welcome everyone. My name is Bradley and I'll be your moderator today. And thank you for joining us here at Netcom Learning. And as a company that provides training, learning, and talent development solutions and wants to promote lifelong learning, we're happy to host today's technical webinar on a first look at SQL Server 2016 in memory technologies. And presenting today's topic is Daniel Bruno. Daniel has been teaching SQL Server and business intelligence classes since 2007. He has worked as a consultant developing business intelligence solutions for international companies for 15 plus years. He also holds several Microsoft certifications, including MCSA SQL Server, MCSE Data Platform, and MCSE Business Intelligence. Daniel is a Microsoft certified trainer. Please bear in mind that this is an overview of a very robust topic, and we have custom workshops that can be tailored to fit the culture of your work environment to address this topic in further detail. We'll just give you a quick overview of the logistics before we get started. To start with, you have the option to adjust the window size to your liking. Simply hit the escape key and find the zoom button on the top left corner of your GoToWebinar viewer. Everyone has been muted except for our presenters today. Also, a PDF of today's slides will be going out in the questions pane in just a few moments. And also, please feel free to submit any questions you have for the presenter here in the questions pane, and we will address them with Daniel at the end of the session. And today's session is being recorded, so you will get free access to the recording in the next 24 hours via email. And let me just take a moment to show you where you can access that recording. On our website, www.netcomlearning.com, there is a free webinars tab here that you can access. And then under here, at the top is all of our upcoming webinars, and you can sign up for as many as you'd like. And if you scroll down to the bottom, you will see recently completed webinars, and today's webinar will be the first one, and you can just hit view recording, and you will be able to access today's webinar. And just as an FYI, we also have a host of other business and IT courses and certifications that you can find if you click on these tabs up at the top, including a number of SQL-related products, courses, and certifications that you can find if you type in SQL in the search function. We also have various promotions going on right now, such as this deal on PMP courses. Netcom Learning has also introduced a Learning Savings Pass and a Learning Voucher Pass designed to offer organizations flexibility when choosing which training programs they need while maximizing savings per employee. And so without further ado, I'm going to hand it over to Daniel to present today's topic. Daniel, are you there?
Yes, I'm here. Can you hear me?
Yes, we can hear you perfectly.
Perfect. All right, I'm going to show my screen. Can you see my screen?
Yep, I see it. It's very clear.
Perfect.
Great.
So, welcome everyone to the discussion of a first look at SQL Server 2016 in memory technologies. My name is Daniel Bruno, and I will be taking you through some very exciting new features that you will find in SQL Server 2016. What's on the agenda? We're going to review column store technology. We're also going to review specifically how it applies to clustered column store indexes, non-clustered column store indexes. We'll see what the differences are and use cases for each one of those. And then lastly, we're going to look at memory optimized tables and see what has been enhanced in that area as well. So first of all, let's take a look at column store technology. We're going to look at some highlights. We're going to look at some how it is stored in the database, specific enhancements that have occurred in SQL Server 2016, some key enhancements, some use cases, and how do we go about using it practically. And lastly, we will go over a demo. So let's look at some highlights. What is column store index technology? It's a technology for storing, retrieving, and managing data in memory. Non-cluster index were introduced in SQL Server 2012, and then in 2014, cluster indexes were introduced. Now, at this point, what Microsoft did was giving us this fascinating new feature, this new technology. However, it had some limitations. It has some caveats. So what they've done in 2016 is improved both the non-cluster and the cluster indexes. And they basically said, you know, before it was there and you could use it for enterprise production environments, but there had to be some workarounds in order to take advantage of these features. But now that those technologies, those limitations have been lifted, it's a lot more straightforward, it's a lot more intuitive, it's a lot more beneficial. The advantage, one of the key advantages of column store technology is the performance. And Microsoft guidance says that you can get up to 10 times query performance gains compared to traditional indexes. Also, the data in the column store index is compressed. So again, you can get some benefits based on the compression of the data, which is up to 10 times compared to data that is not compressed. The storage format of a column store index is very different from a regular disk-based index. And the data is stored in a column-based format, which is why we have the name column store. And then on the upcoming slide, we're going to see, on this slide, we're going to see how the column store index works underneath the hood. So imagine that you have a batch of data coming into your column store index. That data has perhaps several columns and many, many rows, right? So what happens is, the first thing that happens is the data is broken down into row groups. The row groups can vary in size between just over 100,000 to just under 1,050,000 records. And so the data is coming in and is broken down into row groups. If the row group reaches that threshold, which is about 100,000 records, it will go into the column store section of the index, which is where the data is compressed and also where the data is kept in memory. And what happens once it's in the column store is that the data is broken down into columns, broken into individual columns. So each row group in the column store is broken down into individual columns, as you can see on the picture. Now, what happens if you have leftover data that doesn't reach that minimum threshold? That data is kept in what is called the delta store. And in the delta store, again, it's part of the index. You can query it, you can read, write, do everything, but it's not in the column store. Once enough data arrives to the delta store to reach the threshold, again, just over 100,000, 102,000, I believe, and 400, I think that's the exact number, I think. Then at that point, it goes into the column store. And again, everything that happens there is managed automatically by SQL Server. So as a user, you don't have to, it's good to know how it works, but it's not something that you have to manage manually. Now, let's take a look at some enhancements, specific enhancements in 2016. This is not by any means an exhaustive list, but in my humble opinion, this could be some of the key enhancements that might change some of the use cases that were before in SQL 2014. What's the first enhancement that we're going to consider? So the cluster column store index now supports other row store indexes, so like regular indexes on the same table. It also supports primary keys, and it also supports foreign keys. We didn't have this in 2014, but we do have it now in 2016. And that's a game changer. Why? Sometimes, or many times, what you would normally have on a table are primary keys, foreign keys, and that would prevent you from having a column store index on that table. So where could you find a table that doesn't have primary keys or foreign keys? Well, what you could do, for instance, if it's a data warehouse, sometimes dimension tables, large dimension tables, don't necessarily have foreign keys to other tables if you have a star schema. So you could have a column store index on a dimensional table. But very rarely, if your fact tables have foreign key relationships in the data warehouse itself, you may not be able to use a clustered column store index. That's where the non-clustered column store index comes into play in 2014, because with non-clustered column store indexes, you can have those indexes coexist with other primary keys and with other foreign keys in tables. So you would see in 2014 in many production environments that non-clustered column store indexes were used a lot because of the limitation of the clustered column store index. Now in 2016, those limitations have been lifted. So again, you have many different use cases that you didn't have before. So now you would perhaps see those column store indexes being used more prevalent more often. Now, non-clustered column store indexes in 2014 are read-only. So that means that if you're going to add data, you have to have a workaround. Either drop the index and rebuild it, or use partition switching pattern in order to add more data. With 2016, that limitation has been lifted, so you can just simply run an insert statement or an update statement on a non-clustered column store index, and the data will be updated and changed. Lastly, another key feature, in my opinion, is that non-clustered column store indexes now support filter conditions. What's a filter condition? Well, perhaps you have a table with millions and millions of rows, and only, say, 10% of that data is actually actively accessed. And so what you can do is have an index, a column store index, just on a subset of your data in that table. Again, what that does is it helps you on the performance side while minimizes the memory overhead that the column store index will take on the server. We're going to see that on the demo specifically once we get to that. So, what are some of the use cases? We touched on this before, but let's discuss them specifically. The use case for a cluster column store index now is, if you're talking about a data warehouse, then would be a fact tables, large fact tables, and large dimension tables. Because some of the limitations have been lifted, now you can seriously thinking about using cluster column store indexes on fact tables and dimension tables. What about non-cluster column store indexes? With non-cluster column store indexes, the index is actually, let me step back 1 second. Cluster column store index is the primary index on a table, whereas non-cluster column store index is there are secondary indexes on the table. So you can have primary keys, you can have foreign keys, you can have regular disk-based indexes, and those will be the primary indexes, and then the non-cluster column store index will be the secondary index. Now, before these indexes couldn't be updated, now they can. So SQL Server now automatically keeps this non-cluster column store index updated. So if you have an OLTP system, and so with OLTP systems you need quick reads and writes, you need to have your foreign keys, you need to have your disk-based indexes, and sometimes you don't even want to change them because they've been there for a long time. But what you can do now is put on top of that table a non-cluster column store index, which now can be updated, and SQL Server will take care of updating it. And now what you can do is, if you need to run reports and reporting out of your OLTP system, you now have a way to do so. It doesn't replace a data warehouse, but it just it makes life easier. It makes certain things easier. So you can have both indexes, and virtually it means that you don't have to really change the underlying logic of the application, because the two indexes can coexist. Now, how do we use these indexes? The cluster column store index is you have one index for the whole table. So that's why the statement goes create cluster column store index on my table, because it's the primary index for the table. It affects the whole table. With a non-cluster column store index, again, it's a secondary index. And in that index, you actually have to specify which columns you would want to be part of that index. So in many of my solutions right now, they're based on 2014. And if it's, for instance, a fact table, I will have every single column in the fact table, or virtually every single column in the fact table as part of the non-cluster index. Again, with 2016, I will be looking into the possibility of introducing cluster column store index for all my fact tables. So let's look at a demo now, where we're going to see the cluster column store index and the non-cluster column store index. So I'm going to go to my virtual machine that I have on the Azure cloud. And here we have the AdventureWorks database. And this is running SQL Server 2016 CTP3. And here you will find a table, Fact Finance, slightly modified from your standard Fact Finance table in AdventureWorks. And here you will have a primary key, and you'll have foreign keys, as well as some regular columns. So let's take a look at the results of this table. Let's go back to the beginning here. Let's take a look at this. I have statistics on, because this way we're going to see how we would compare the performance between a regular row store index, disk-based index, compared to a column store index. So we're going to run the query, and the results are returning. And if we go back to the messages tab, we see here the CPU time and the elapsed time that is taken to produce this query. Again, you see this information because I have statistics, time on and IO on. Now I'm going to clear the buffer, and I'm going to create a cluster column store index on this table. So notice that now I have a cluster column store index. Now this is my primary index, but at the same time I also have a primary key, and I also have a foreign key relationships, which you couldn't have in 2014. So again, major difference, game changer, opens up the use cases in a major way. So I'm going to run this query now. Again, the same query as before, but this time on a table that uses a cluster column store index. We're going to see the analysis of the execution times, but just keep in mind that this is a very concocted example. It may not necessarily prove the performance of the column store index, but this is the methodology that you would follow in your systems where you work to compare a traditional disk-based row store index with an in-memory column store index. And here you see that you would compare basically now the CPU time and the elapsed time with the column store index, and compare the performance benefits that way. Now, we said that this column store index is updatable, so let's prove that. And you notice that we're able to update the data. And again, these are a small number of records that we insert in one at a time. So likely this is going to the delta store. And again, when it reaches that threshold, they will be moved to the column store part of the index. So that was the cluster index. Let's try to create a non-cluster column store index. So first, let's try to see if we can have both indexes at the same time, a non-cluster column store index and a cluster column store index. And you can't. You can have one of the two, but you cannot have two in-memory indexes at the same time. Not if it is cluster and non-cluster anyway. So we're going to drop the cluster one, and we're going to recreate the non-cluster one. But notice here that I have a filter condition. I have a filter condition that says that this index is only going to apply to data where the date is 2013 or greater. So the latest year. I think 2013 is the latest year available in this table. So I'm going to run this. So I have now a non-cluster column store index with a filter condition. So again, the filter condition is new to 2016. And again, in 2014, if I would have created this index, now I could no longer run an insert statement straight into this table. This statement would fail in 2014. But now it's succeeding. Why? Because non-cluster column store indexes in 2016 are updatable, and SQL Server maintains the index and the table in sync. So that brings our first demo to an end. So let's go back to the slide. And now we are moving on to memory optimized tables. We're going to see some highlights. We're going to see how we can use it, when we can use it, and a short demo. So memory optimized tables reside in memory. A copy can be maintained on disk, but only for durability purposes. There's an option where you don't have to maintain a copy of the data on disk, but you typically normally use that if you really don't care about losing the data in the case of a server crash. It was introduced in SQL 2014, but with many limitations, which vastly reduced the amount of use cases. In 2016, most of those limitations have been lifted. So now you can use in-memory tables virtually in the same way as you could do a regular table. There's still some limitations, but again, now it's almost the same. Why is it so fast? Well, obviously it's in memory, so it's going to be fast. But then also the rows in these tables are versioned to allow concurrent access, read access, and write access at the same time. So let's look at some of key enhancements. Again, there are many more enhancements, but in my humble opinion, these are some of the ones that I just thought that we should highlight today. In 2014, the maximum memory recommended for an in-memory table or a memory optimized table was 256 gigabytes. In 2016, it's 2 terabytes. In 2014, if you wanted to have a column as part of an index, the only collation available was being 2, whereas now in 2016, all collations are possible. In 2016, you have support for alter table. So before in 2014, you had to drop the table and recreate it if you wanted to make a change. Now you can do an alter table statement. You can run an alter table statement. It supports parallel plans in 2016, and it supports transparent data encryption. So again, these are some of the key enhancements that might open up the amount of use cases that you might find for this technology. When can we use it? When you have a situation where multiple sources are trying to insert data into a table at the same time. Again, if that table were to be in memory, you obviously would be you would have less of a bottleneck there. Where you have a combination of reads and writes, and again, you want to minimize locking. So an in-memory table, memory optimized table could do the job very nicely. What about if you have a store procedure and a series of store procedures, updating balances, deleting records, updating records, and inserting new records all at the same time? Again, in-memory tables can help you. It can help you in situations where you have to act very quickly and you need to provide a low latency environment. And in situations, for instance, where you need to provide session state management. In this particular case, perhaps what you might choose to do is not to save and to make sure that we said before that you could have the data for durability purposes be a copy of the data be made on disk. But if it was a session state situation that you wanted to provide a feature, then you could say, I just want the data to be in memory. And again, then in that case, you would suffer no disk footprint for that data. How do we create a table, a memory optimized table? It's virtually the same as a regular table. Notice here the create table statement. We specify the columns. Notice first at the very bottom and on the width keyword, here we have the option of memory optimized on. So this is one of the key differences, how you distinguish a memory optimized table. The other key difference is this type of index. We have a non-clustered hash index, which is a memory optimized index. And we have here the bucket count, which is a new concept for memory optimized tables. And basically you have to calculate it to see what would be the correct count for your situation. So let's look at a demo of memory optimized tables now. Demo 2. So I have here this memory optimized table. I'm going to run this statement here. And so now that I have the table, you will notice here it appears. It's called dim reseller in memory. And so at a first glance, it doesn't look any different from any other table. Columns, a primary key. If you look at the properties, however, you will see that memory optimized is set to true and durability is set to schema and data. Again, you have other options such as schema only. Now let's try to insert data into this table. So now we've inserted 100 rows. So notice that we're treating this table just like as a regular table. And now we're going to select from this table. Again, we are treating it just as a regular table. So let's go back to the presentation. We're almost there. So in summary, we've reviewed column store technology. We've seen what it is, how it's stored. We've looked at some of the key improvements that we've had in column store technology when it comes to cluster column store index, how now you can have cluster column store indexes on tables that have foreign keys and that have primary keys and whatnot. They can coexist. So that opens up the amount of use cases that you can have for this technology. You have now non-cluster column store indexes where they can be updatable now. So now you can have in your transactional systems, you can have a non-cluster column store index on top of your regular tables, and your regular application will run just as it always has. But then if you want to run some reports directly from your OLTP system, now you have this in-memory index that will facilitate the reporting. It doesn't replace a data warehouse, but it just facilitates some of the reporting directly from OLTP systems. And then we looked at memory optimized tables, where a lot of these limitations that you had in 2014 have been lifted. There's still some, but still most of them are not there anymore. And so again, now it opens up a new world of possibilities for this specific feature of in-memory technology. So that brings our demo to our presentation to an end. I just wanted to take this opportunity to thank you all for attending this webinar, and I hope you enjoy the new features in SQL 2016.
Daniel, thank you so much. That was very informative. So let's get to some of these questions. So there's a question asking, will memory optimized tables be Enterprise Edition only in 2016?
That's a very good question. I have to get back to you on that one, actually. We are definitely using SQL Server 2016. We're using Enterprise in my environment, but I cannot remember whether Standard will have that feature as well. Yeah, that's a very good question.
Okay, and then let's see. Someone's asking, how about 1 million distinct rows? I'm not sure exactly what they were pertaining to, but they were asking about 1 million distinct rows.
For an index, you basically have to, I guess maybe you're thinking about the bucket count option for the index on a memory optimized table. Microsoft Online gives you basically if you go there, you will see all the guidance and instructions to arrive to the right settings for your memory optimized tables, and some of it might be a matter of trial and error.
Great. All right. So if you guys come up with any other questions, you can send them to webinar@netcomlearning.com, and we'll filter them to Daniel, and we'll definitely get those answered. Before we go today,
please.
Daniel, do you have any other any comments before we end today's webinar?
No more comments. Just again, thank you all for attending, and I hope you enjoy the presentation.
All right, thank you, Daniel, and have a good day, everyone. And tell your friends and colleagues about our webinars and other courses. And have a great day. Bye, guys.